Alright, so we are going to get into the advanced EIGRP option. Guess what we have here? Unequal cost load balancing, authentication, path manipulation using the bandwidth delay command, and some WAN consideration, stub in EIGRP, and few more. Let's see. Let's go in. You see, we saw that in newer version auto summarization is off, meaning in newer version it will not summarize, but in older version, meaning in the popular version, in the version which many companies are running EIGRP, that will do summarization by default. But 15. Later iOS version of EIGRP, they don't do this. No auto summarization in the newer version. What is auto summarization? You got multiple subnets like 10.1.0.0/16, 10.2.0.0/16, 10.3.0.0/16. Let's assume these three are running on this router. When this router advertises, it will advertise 10.0.0.0/8. That's the summary of this three. This is by default in the popular version or in the older version, whereas in newer version it is just sent like this. All three are sent separately without summarization to the neighbor. Both has got advantage and disadvantage. Earlier they thought summarization is good. Instead of sending three separate updates, we are going to send just one update. So in the beginning they thought summarization is good. Less bandwidth. Not only that, when the update is received on the remote router, the next router will not need much processor to process it, will not need much buffer to accommodate this route. Just one route it needs to write into the routing table, not three routes. I just written three routes. In the real world it may be 300 subnets. Who knows, it may be 1000 subnets /2410 network. So summarization is good. You see, when we have little food, then eating less food, small amount of food daily. So you may take little and eat so that you can survive for long time, long days. Because you got only little food, there is no other hope. But when you have plenty of food, talking about little food, saving food is useless. Correct? Same thing. Now the advancement has made plenty of food for us, meaning you got enough of bandwidth, big processor, big buffer. So the bandwidth and buffer and processors are no more a big constraint. Earlier days, reaching 100 meg itself was a big task. Having 100 meg bandwidth wire is very costly. On those days, summarization is seen as good. We summarize and send. But the summarization has caused a lot of issues. One of the issues I also faced, on those days I was not that good in routing switching. Because of that, these are the subnets 10.1, 10.2, 10.3, here 10.4, 10.5, here 172 something. Because it summarizes by default, EIGRP summarizes by default. On those days I was not aware of this because my first CCA was security. I did not learn that deep those routing concepts on those days. So this router B was advertising 10.0.0.0/8. This is also advertising 10.0.0/8. Will they learn each other? No, they don't learn each other. This router says, hey, I also have 10 network. You no need to give me. I also have 10 network. This router will say when this advertisement comes, I also have 10 network. It's okay. I cannot take yours. So they never learn each other. And when I ping from this 10.1, 10.4, the ping is not happening. VPN is up. VPN is up, but the routing is not happening. When will this routing happen? When you cancel the summarization by saying no auto summary. If this would have been done in 2009, year of 2009, it would have been good. I was not aware of these things on those days. And only when you say no auto summary, the detailed route like 10.1, 10.2, 10.3 will go and 10.4 will come. See, 10.4 is coming. This router don't know about 10.4. It will learn 10.4 now. When you cancel the auto summarization only, the detailed subnet goes. If both send 10.0.0.0, they don't learn each other. Oh, why you are giving me 10? I already know 10 directly connected to me. Why should I take yours? Summarization was the big problem. See, this is a drawback. Though summarization is seen good, sometimes we end up with a problem like this. As a security guy, it's not that it was not easy for me to learn those things in the beginning days, those routing concepts. Same way, there are many engineers, security engineers, who do not know about the summarization in production, so they will not be able to troubleshoot unless auto summarization is cancelled. So summarization, when you have enough of bandwidth, big processing devices, then there is no need for summarization. But on those days, we were not having this big bandwidth. I'm talking about like 2003, 4, 5, 2000, up to 2000, let's say 2009, 8. In those days, 1 gig link was very rare to see. 1 gig link. 100 meg was there. So on those days, we were expecting small route update, small routing table. So summarization was appreciated. It will summarize to major network boundary. What does it mean? If I have 10.1, 10.2, 10.3, It will summarize to major network boundary. What is the major network boundary? These all belong to /8 class A. Major network boundaries by default. The subnetworks are summarized to single classful major network boundaries. If you don't like, we say no auto summary so that these contiguous networks can be supported. Now that's about auto summarization. We also have manual summarization at any point. Manual summarization means what? Manually you can summarize on the interfaces so that one neighbor will receive a summarized route update, the other will receive detail. For example, if I have router 1 with 10 meg wire connected to a very old router, and I got 100 meg wire connected to a new router, I want summarized route to go to the old router, detailed routes go to new router. So what I can do is globally I can say no auto summary. When I say no auto summary, it will try to send, or it will send a detailed route updates to both. But I don't want the old router to get detailed routes because it is not having enough buffer, processor, as well as the bandwidth. So what I can do is I can go to this particular port where the bandwidth is less. I'll go to this one port and say summarize to 10.0.0.0/8. You know, so when you do manual summarization like this, router 1 now needs to advertise the summary route to old router. But without having route in the routing table, EIGRP cannot advertise something without seeing that in the routing table. For that, it creates a route, the summary route, pointing towards null interface. See, if a router needs to advertise something, that something should be there in the routing table. Now the summarization you are doing is for one router, not for all the neighbor routers. Even it is for one router, the route should be seen in the routing table. So what it does is, this may be summary of 10.1.0.0, 10.2.0.0 and so on. This may belong to loopback 1, this may belong to fast Ethernet 1, whatever. But when you summarize to 10.0.0.0, the summary belongs to all these interfaces. So now if it points towards loopback 1, then there will be confusion because 10 is also on F01. If the summary route point towards F01, then also confusion. So sometimes packet will go here and come here and then go here and come here. It may cause loop. So to prevent that loop, the summary route, which is common for many routes, which is a summary of many detailed routes, that summary route need to point towards a dummy interface, a neutral interface called null interface. So now the route can be advertised a summary route to the old router. I'm going to quickly show you this. Yeah, so router 1 is going to have some subnets. We are just simulating some subnets by using loopback interface. You may, in the real world, you may be learning those routes from some physical interfaces, but here we are just simulating like 10.1.0.1/24 loopback. Okay, just for your reference, I have written these things here. And now here we are going to have 192.168.0./24, and here 192.168.1.0/24. Now let us configure the routers first with IP address. On this router 1, the interface F00. What is the IP address on F00? Come on, can someone say that? What is the IP address that you see on F00?
216.0.1.
Yeah, 192 IP address. 192.168.0.1. 0.0 is the network, so I'm giving 1 here. On the other side, I'm going to give 2. The mask, because it is 24, it is 255.25250. Interface F0/1, no shared. IP address is 192.168.1.1. 255.255.255.0. See? It's 1.1. 1 is the third octet here. So 1.1 I have given here. 0.1 I have given here. Next. And we decided to, what is that? Given. See? Show IP interface brief. The interfaces are up. Now I'm going to create this 3 logical interface so that we can have 3 networks. So this is the purpose of loopback interface. One of the reason why we need loopback is we want to simulate some network. We don't have a real network like 10.1, 10.2 and 10.3, but we want to simulate. We want to show to the router as if we have some networks. The loopback interfaces, if you ping, they will respond same like a real physical interface. So for testing, people used to create some loopback interface network. So networks they will configure on loopback interface. If this loopback interface responds, then you may also have a LAN network starting with 10.1, 10.2, 10.3 that will also respond. So it is like simulating LAN networks. But there are various other purposes of using loopback interface in different places. In this place, this is the necessity of loopback interface. We are simulating some networks. Let's do. Interface loopback 0 IP address 10.1.0.1 255.255.255.0. Sorry. this will override the other one. So you don't need to cancel and put. You can just do like this. Next, interface loopback 1. See, loopback interface, you no need to type no shutdown. Why? When you create, it brings up the interface. You no need to say no shutdown. But the physical interface we are not creating. For security reason, it will be down. And we have to say no shutdown on the routers. On the switches, no problem. Fine, I'm in router 1 and on loopback 0 we have finished configuring. We are in loopback 1 now. The IP address is 10.2 here. Likewise, interface loopback 2. Here. Done. Now what is next? Show IP interface brief. We got these interfaces and IP address. These three newly created logic virtual interfaces. These are physical interfaces. Physical interfaces, we say no shutdown. That is why it is up. Why this side is down? Because the other end of the wire is not up. Means new router and old router is not configured. So the line protocols are not working. When this router says hello, this router says it's sleeping. It's not responding. And it says hello. Means line protocols are not running. So you need to wake it up. Only then this will come up. See, for example, I'll show you. On the new router, I'll go. New router. Interface F0/0, I say no shutdown. You see, when I say no shutdown here, there also it will come up. See, it has come up, line protocol has come up. Now you check, it's up. Likewise, if this needs to come up, here this has to be, this we need to say, wake up. Let's wake it up. Done. Now if you go to router 1, you will find all the interfaces up. What is next? Let us finish the configuration, basic configuration on the other side. I'm in the new router. New router needs a name. Host name new. So when I say new, what does it mean? I mean here has got more bandwidth, more processor, just assumption. IP address 192.168.0.2. I already say no shutdown. Now on the old router, host name old, interface F00, IP address 192.168.1.2. Done. What? Control Z is not working for me. Control, you're not. Okay, it's okay. Now what is next? I just want to ping the directly connected 192.168. The old. I should be pinging 1.1. This is directly connected, no? So this and this are pinging, directly connected pinging. Likewise, I'll go to new and ping R1. Ping stands for Packet Internet Grouper. What it does is it sends ICMP echo packets. When the destination is available, it will send ICMP reply packet. So I say ping 192.168.0.1. What I'm doing is I'm generating an ICMP echo packet to this address. from the I mean router 1. I should ping from router new ping 192.168.0.1. I'm going to get a reply because this address is available. It's there configured on router 1. So we are able to ping router 1. If you want to ping from here, you need to ping the new router whose address is 192.168.0.2. What is this? What mistake I did? Oh, 2 times. Oh. Fine. Now it's time to enable EIGRP. Look at this. I say router EIGRP. Put any number between 1 to 65535 as autonomous system number. See, from this what we learn is for autonomous system number there are 16-bit given. 65535. That's all we should know. 65535 shows that there are 16-bit given for autonomous system number. So I'm going to give 10. And then I'm going to simply say network 10.0.0.0. What does this mean? Advertise or run EIGRP on all the interface that begins with 10. You see, I just put 10. 10 is running on all these 3 interface. You can see here, show IP EIGRP interface. You see, all 3 interfaces are running EIGRP. You know why? Because all 3 has got 10 in the beginning. Show IP interface brief. You can see that. Loopback 0 has got 10, loopback 1 has got 10 in the beginning. And now I'm going to say again router EIGRP 10 network 192.168.0.0 and then 1.0. This is /24 mask by default, so I have to say this. Alright. What's next? I'm going to see now EIGRP running on both physical and loopback. Show IP EIGRP interfaces. You see, it runs on both physical and loopback. When I say 192.168.0.0, it runs on this. 10, it runs on this. This is for 00 interface, this is for 01 interface. EIGRP is running, but it's an older version. You see, show IP protocol. If you see in the older version, the summarization is happening. What it does is it takes all these 3 subnets 10.1, 10.2, 10.3 and it is summarizing like this for both interfaces that connects to new and old. Yes, so that's for both. Let us go and bring up the EIGRP on the new and old router EIGRP 10 network 192.168.0.0. See, immediately the neighbor has come. This is the IP address of router 1. With that neighbor using EIGRP 10, a new adjacency has happened. It has come up and dual algorithm was involved. We saw EIGRP uses dual algorithm. You can verify this by typing this command show IP EIGRP neighbor. This is the neighbor address. You see the timer here, 13, 10, 14. After 10, immediately 14. What do you understand? Every 5 seconds, the hellos are coming from the neighbor. This neighbor is sending, the router 1 is sending hello every 5 seconds. That's why the countdown never reaches 0. If hello don't come from this neighbor, the countdown will reach 0 and the neighbor will be thrown out, you see. 13, 12, 11, 10, again 14. Okay, one more time. 13, 12, 11, 10, 14. So every 5 seconds, hello is coming. That is what maintains the neighbor. Let us go to this old router and enable EIGRP. Router EIGRP 10, network 192.168.1.0. Boom. So we got another neighbor. Let's now check the routing table. Show IP route. Look at this. We got a summary route. Summary of all these three. If you will ping from here 10.1.0.1, it will ping. If you ping 10.2, it pings. 10.3 pings. Yeah, so it pings. Though we got a summary of it, we will be able to ping using the summary route. But if the STEN network is here and there, and if you do summarization, like I had in the exam, discontiguous, that won't happen. So we used to cancel the auto summarization in such scenarios. Or when you have enough of bandwidth and process, you want detailed routes, you can say router EIGRP 10 no auto summary. When you say no auto summary, the resynchronization happens. Now you see the summarization is not currently effective. It's not. As a result, if you go back to the routing table here, earlier it was a summary one, but now it's a detailed one. I'm getting a detailed route on both router 1 and router new and router old show IP route. But I do not want this detailed route in the old router. I'm okay to have it in the new router, but in the old router I don't want this. I don't want this. If I don't want this, two ways. Put auto summarization, but the problem is even for the new it will be summarized. I just want only for old summarized one. So what I can do is I can go to this interface F01 of router 1. Interface F0/1 IP summary address EIGRP 10 10.0.0.0 mask 255.0.0.0. I am saying summarize like this. So a resync happens again only with that. Anyway, it is resyncing with all the neighbor. Now let's go and check. When you see here, auto summarization is not in effect, but show IP route, you got a null interface having the summary. See, if a route need to be advertised, the route should be seen in the routing table. For that purpose, we got this here. It is created because it got created because we went under the interface and say we want to summarize like this. But we don't want to summarize for all neighbors. We want only for this neighbor. That's why we configured on the interface F01. See, I configured on show run. I configured on F01. I configured this on F01. This 5 is the administrative distance. The default administrative distance for EIGRP summary route is 5. If you don't give also, it will take 5. I didn't give actually. This is the command on this interface that connects to the old router. As a result, if you go now, earlier you were having detailed routes, but when I configured the summary, I got a goodbye message. What happened? When I did some changes, router 1 said, bye-bye, I'm going away. And then it came with a new relationship. What relationship? Summary relationship. Let's check. Show IP route. Now you see, this router receives the summary route, whereas the new router, this also got the goodbye message, but it got the same old routes again. For the new router, you got a detailed routes. For the old router, you have only the summary route. Hope you understand. I hope that you understood what is manual summarization at any point. Any point means go to any port and do summarization as you like, which is not supported in OSPF. Only RIP and EIGRP supports that. Even in RIP you can do this. Instead of EIGRP you put RIP. In RIP also you got that command, you see. Interface F0/1 IP summary address. Sorry, it is there in a RIP also. In this simulator it's not available. It is available in RIP also. Fine. Let's go back. So manual summarization has the following characteristics. Summarization is configurable on per interface basis. That's what I mean, summarization at any point. When summarization is configured on an interface, the router immediately creates the summary route pointing towards null 0. I showed you. That is to prevent loop. Next, when the last specific route of the summary goes down, the summary will be deleted. So we saw like 10.1.0, 10.2.0.0. For this, we saw the summary route is 10.0.0.0. When will this advertisement stop? It will stop only when all these three goes off. If all these three are down, this also will go down. If any one of this is alive, the summary will be alive. That's the meaning. When the last specific route of the summary goes down, the summary is deleted. Next, the minimum metric of the specific route is used as the metric of the summary route. Because it is loopback, there was no metric, so the default is 5. But if you have physical interfaces, the metric of because we have not specified the administrative distance 5. But the metric will be the minimum metric. We had loopback interface, all the loopback interface got same metric. If it is physical interface, if 10.1 has got 5 as a metric, 10.2 has got 15 as a metric, 10.3 has got 20 as a metric, it would have used 5, the small metric. Now this is the command to disable summarization, turn off auto summarization, and this is the command that I used under the interface, manual summarization. Right? We did this. We did this both, saying no auto summary globally, and then going under the interface and saying summarize like this. Yeah. Here comes another important topic called unequal cost load balancing. EIGRP supports equal cost load balancing as well as unequal cost load balancing. By default, equal cost load balancing is supported. Because the variant is set to 1. So unequal cost load balancing is disabled. But if we can change this variance, unequal cost load balancing will also be supported. Equal cost load balancing up to 4 by default. In some version, maximum up to 6 you can have. The number of entries is configurable. By default it is 4. You can go up to 6. In some version of EIGRP you can go up to 32. It's not 6. Up to 32. You can specify the number. The max path command, that's the command, max path. Now this is the variance that I was talking about. If you change the variance, it can even support unequal cost path. Variance, don't forget, we go under the router mode and we use the command variance. So here we will see an example, and then we'll come one more time tomorrow, and then we'll see much detail here. As of now, let's just go through this. Look at this. Router E has got 3 paths to reach network Z. In this, if it goes via B, the feasible distance is 30. What is feasible distance? The total distance. Advertised distance is 10. B is advertising 10, correct? 10 is what you see in this side. And the metric between E and B is 20. So totally 30. 30 is the feasible distance, 20 plus 10. Via C, advertised distance is 10. And total distance, FD, is 10 plus 10, which is 20. Via D, the advertised distance is 25. The FD is 25 plus 20, 45. Now, the lowest FD is the successor route. So, this is the successor route. Going via C is the successor route. Now, to become a feasible successor, the advertised distance should be less than the successor value. Is this less than successor value? Yes. So B will be considered as a feasible successor, backup route. But going via D is not considered as a backup route. Why? 25 is not less than 20. So this won't be seen in the topology table. D is never considered to go to network Z because the advertised distance is greater than the successor. It should be less. It is greater. Now we understood this is the successor and this is the feasible successor. But by default this will not be used for load sharing. By tuning the variance to 2, what we are saying, by tuning the variance to 2, what we are saying is take the successor value. What is successor value? The lowest FD. The electoral routes metric. Multiply it by with 10, multiply it with 2, that is what variance. What is the answer you will get? 40. And if any route is having less than 40 or equal to 40, you can consider as a successor. So because this is less than 40, this path will also be considered as a successor even though the FD value is different. You are saying it is okay. Just multiply the successor value and the outcome is 40. If any route is less than 40 FD value, you can consider for load sharing. So with variance 2, router E choose B to get to Z. Earlier it was choosing C, now it also chooses E. This is what called as unequal cost load balancing. For unequal cost load balancing, what we need to have is, first of all, we need to have a feasible successor route. D is not considered because it is having advertised distance higher than successor value. But B can be used as the successor by changing the variance, because B is available in the topology table. So we change the variance to 2. See, if we change the variance to 3, 20 into 3 is what? 60. It is of no use. Why? Even though this is less than 60, it cannot be used. Why? It is not even considered, no? In the topology table, feasibility condition, to prevent loop, it won't take. Advertised distance is greater than the successor value. Yeah. So more detail about this is what our tomorrow's class. I'm going to explain this one more time with lab. Thank you so much for joining today. See you in the next.